Hello and welcome to this Swift programming video. My name is David Thorne. In this video we're going to be talking all about how to use Bitwise operations to send packets between one IoT device and another using secure means, but also a very easy mean as well. Now obviously some of these IoT devices don't have enough processing power to do some full encryption techniques that are available in the world. So you've got to find some ways to mix up that data, to scramble the data just enough that other people cannot read that information that's being broadcasted over the network. And that way we can use a shared key. Obviously in this situation you would then be hard coding this shared key on the IoT device. You would have programmed it into the binary. Or otherwise you would then create some shared key over the network upon initialization, and that shared key would all stay in memory to make it even more secure. But in this example, we're just going to have it hard coded in here in the shared key. And as we can see here, we have a simple message, a message to send over the network to an IoT device. And we have then the encrypted bytes here, which is what's going to return from our encrypt function. And then we then decrypt it on the other side using the shared key, and then we print it out if we have a message. Obviously at the moment decrypt is just returning nil, and our encrypt is just returning an empty array. So with that said, let's look at now how we can encrypt this message using this key to this array of unsigned integers or 8-bit integers, and then how we can decrypt it back into a string or an optional string if necessary. Okay, now before we go over the encryption, let's just go over looping through this message UTF bytes just to show you if you haven't seen it already. And we'll just say value in message.utf, and we'll print this out as we go along. Nice and simple, and as you'll see, it will convert it into all of the UTF codes that we want to create then our array of unsigned integers. Okay, so this is basically what we want to do first of all. So once we come here, we just say message UTF-8, sorry, and now that we have this integer, this 8-bit integer, we now need to use exclusive OR, right? And we're then going to use the key for this. That is basically all we're going to do. Is we're just going to convert all of these individual characters within inside of the string, and then we're just going to exclusive OR into another shape or form of it. And as long as this shared key is secret, then it's just going to be a little bit scrambled. Obviously, if someone knows this shared key, then they can decrypt it as well. So going back, we're going to basically do the reverse. We're going to take, let's just say data here. We're going to take the bytes and we're then going to map these instead. And we want to then do exactly the same once again, and to then to decrypt them here. And now we can just return string, and then just saying the bytes here is data, and then the encoding is going back in the other direction to UTF-8. And when we run this, you'll see here that we print out all of the bytes within inside of the string, then a message sent over the network to IoT device. Nice and simple. So this is a really nice, easy way, just before you send that data over the network, that you know it's been scrambled just that little bit, and it adds a little bit more of security to the communications that you send and receive through the network. Okay. Is it necessary? No. But does it make your network securer? Does it make the packets sending backwards and forwards securer? Yes. If you're actually able to use encryption techniques and you have the processing power to do that, then please use that instead of this. Okay. But if the microcontroller or whatever it is that you've got within inside of your network is really small, has low memory, not lots of processing power, then at least go through this, because all it is it's just mapping it to another integer and then sending the data over the network. It's one loop that it's got to do a little bit more, and this is very cheap on the microcontroller as well. And I'm always a fan of trying to break stuff just to prove that it does or doesn't work. So let's just change this key now. So let's put shared 1 and shared 2, and let's use shared 2 on the decryption instead. And let's just increment this number by 1 to 7, and just to show you what message we get out, we get some random rubbish sent out. You could argue that this is a very primitive form of encryption. In order for the hacker to be able to get that one data on the other side, there are 256 different permutations of this one shared key on the network that's going available if you are only going to use an 8-bit or just 1 byte shared key. Obviously, you could extend this to be even further to use more bits for the encryption, but for this example, 8 bits was just enough. So let's just change it back to this now, and you can see that we get now the data that we want. And if we change this to B and we run it again, we can still see that we get absolute nonsense spat out. And there isn't a single piece of information there that makes any sense that we could go there from. So with that said, I hope this would give you at least a little bit of information. The hacker would at least have to send, say, 255 requests before getting the final one. If we were to use FF as the actual encryption, then they would have to then check 256 or 255 other ways of doing it before they got the right one. So with that said, I hope that you've got something out this one video. Remember, security is the key thing, and adding even the smallest level of complexity, as in to a hacker, to scramble that data is worth it. Okay, with that said, don't forget to like, subscribe, share this video, and if you've got any questions, feedback or concerns, as always, let's start a conversation in the comment section down below. My name is David Thorne. Thank you very much for watching. I'll see you in the next video. Ciao, ciao, and goodbye.